15. So basically, at this point, we have been talking about our spinal nerves, which is our peripheral nervous system. We talked about the brain and the spinal cord, our central nervous system. And now we're going to see how our autonomic nervous system is going to be responsible for maintaining our internal environment and how it's going to have the route for picking up that information by way of the spinal nerves and sending information to the central nervous system. Does that make sense? Yes. Okay. So, pull our little trusty model out right here and try to keep in mind our central nervous system, peripheral nervous system, and now we're going to kind of focus on what's going to be known as this autonomic nervous system. The one that is going to deal with our viscera. Now, viscera is going to refer to the organ of our body. One of the things about the organs, when you begin to think about the liver, the intestines, the stomach, the bladder, all these different organs of the body, yes, they're innovative. Yes, things can go wrong, and they have to let us know. And they are constantly being monitored. The difference, the control centers. Now note my terminology. The control center for these organs, respiration, breathing, digestion, reproduction, okay? This is getting controlled by mostly areas in the brain stem. They are going to be control centers located in the brain stem, okay? So, this is maintaining our homeostasis. Now, the autonomic nervous system, the visceral, well, one of the things about this system, the job of this system, keep the body at homeostasis. Keep the temperature at 98.6. Make sure the blood pH is correct. Make sure that urine production is taking place. Make sure that we're digesting our food. Make sure that we're getting the nutrients. Do you see where I'm going with this? All right. It responds to the information it gets, and because of this, we are going to have a section referred to as parasympathetic and sympathetic. Their job is, of course, maintaining the homeostasis, and because of what these divisions do, it's termed fight or flight. Ever heard of that? because one of them prepares the body for action and one prepares it to calm down. The two working together maintain the homeostasis of the body. How else? Now, note what I just said. The two working together maintain homeostasis of the body. How else do we know it? How else do we know fight or flight? Okay, so maybe I were to say, okay, you've got to get up and give a presentation in front of class. Fight or flight now. Like,
well,
yeah.
you might want to run, but
What does it do to the body? What does it do to...
heart rate.
Speeds up the heart rate, speeds up the breathing rate.
Like eliminates your need to like urinate or
Yeah, you might get affected with the urinary system. You might feel sick at your stomach. You might begin sweating. These are what happens when that system kicks in. Even though it's termed auto. Everything we just mentioned was precipitated by what? What happens for me to precipitate that, Andy? But what happened for, even though I'm saying the system is auto, what happened for you to be able to affect it? I thought about it. So, I thought about it. Now, autonomic, meaning auto, I mentioned that the control comes from the primitive region of the brain. But, what did I just tell you? I had to think about it. What? My cerebrum. Is that the primitive? No. It's the higher order. Therefore, even though the system is auto, we have the ability to affect it. Okay? So, it is, okay, the autonomic nervous system, it is a motor portion because we get effects, all right? The sensory portion is going to be these centers in the primitive region of the brain picking up the information from the body. Now that we are focusing on the system for the inside of the body, where are my receptors going to now have to be? Inside. The outside receptors were located with what part of the nervous system? My peripheral. I'm now focusing on my autonomic system. I'm now going to be dependent on receptors that can monitor in internal conditions. Does that make sense? Okay? So, this system, we're going to have some control over glands. What type of glands am I now referring to? Before, when we had glands, okay, we were like, well, maybe that could be a sweat gland or an oil gland. We're going to now have focus on the glands such as the adrenal. What is found to the interior of the body. Adrenal is a huge one. Now, smooth muscle, most definitely. Stomach, intestines, bladder, reproductive, most definitely. Whoa, whoa, whoa. What's this cardiac that's mentioned? What does cardiac mean? My heart. I'm going to say this a lot. The heart is innervated. However, it in no way is controlled by the nervous system. We can affect it, meaning making that heart rate increase and decrease. But the heart itself is totally controlled by itself. It has no outside control. You'll learn that when we get to that chapter. Innervated, but not controlled by the nervous system. Affected, yes, but not controlled. Since we're dealing with our organs, their viscera, we refer to this as the visceral motor system, because whenever it gets monitored, the effector, something that carries out the response. The reason I'm kind of emphasizing this, based on what I saw with the test, I'm not getting a lot of people listening to what I'm saying. So once again, I'm trying to emphasize important information you're going to need when it comes time to go into your program or take the test for your program. So, the visceral motor system, okay, organs, all right, an effector is what we're telling you is carrying out the effect of the nervous system. It's going to be involving viscera of the thoracic and abdominal and pelvic cavity. Kind of push everything together in that abdominal. We're going to see that in the body, what we're going to say is the body wall, it can affect blood vessels, sweat glands, and piloerector muscles. What is that? The hair follicle. If you remember from part 1, when you learned about the accessory structures, the hair, okay, the hair follicle has attached to it the piloerector muscle. That's actually muscle that is smooth muscle. We don't control that. It's controlled by our autonomic nervous system. Why? What does it mean?